Hello everyone, welcome to Menta. My name is Pranay Sharma and I'll be your lecturer for this term. I'll be taking factorization into our consideration for today's topic. And the prerequisite for this particular stuff is you should know what polynomials are before we actually go in deep analysis of what factorization is and how do we, factorize a polynomial because this particular topic deals with factorization of polynomial of higher degree. Fine. So let us get this started. I hope my screen is visible. Although the introduction part given here is different because we have directly started this with polynomials, but before we actually go into factorization, I just wanted to give you an understanding of what do we understand by polynomials and how they are different from algebraic expression. So allow me a moment. Let me jump to whiteboard. I hope my whiteboard is visible. All right. So what do we understand by an algebraic expression? Just a second. An algebraic expression and how algebraic expression is different from polynomial. Right. So this is our priority. We need to understand what exactly this term is, and then we'll be going with further classification. Let us understand this with the help of an example. Now, suppose if I say that we have one variable which is x, right? So x alone can be treated as what? A term. That means x alone is a term. Now, few of you may also comment on this that sir, if we take 7, right, which is a number, minus 7 plus 7, irrespective of its nature and sign, let us consider this only in terms of magnitude. I am taking 7, right, positive 7. So this can also be treated as a term, right? Now, when I'll be, applying any algebraic operation in between them. Now, let us say I'm adding these two terms. Let us say this is term 1 and this is term 2, and I'm adding them, right? So this is what our, addition will look like, right? And this particular stuff is known as an algebraic expression, A. That is what we have classified. So we can say that, sir, in algebraic expression, if we, write it like this, right, that is also possible, right? This can also be treated as an algebraic expression. Say I'm using 7, you can use any other number, right? However, this can also be treated as an algebraic expression. Fine. Then how this particular term is different from what we are going to deal in this particular topic, that means factorization. We will be dealing with polynomials. What exactly polynomials are? Those algebraic expressions which follows rule number 1. We have two rules dedicated for this. Rule number 1 is the power to the variable should be a whole number. Power should be a whole number. Now, what do we understand by this? Whole numbers are the numbers starting from 0, right? So if I say 7, if I'll be multiplying this as x to the power 0, right? This is nothing but a term, right? And rule number 2 is division is not allowed. So let us say x by 7 is an algebraic expression. This can be considered as an algebraic expression because we have an arithmetic operator in between, which is division in between two terms, right? But can we consider this as a polynomial? There are chances, right? According to rule number 1, the power should be a whole number, and this power should be a whole number of what? It should be related to variable, right? So that means this can be potentially considered as a polynomial. However, if we go with this, then let us say we have x square here. Then this is clearly discarded because this disobeys rule number 2. All right. If we say 1 over x, again, this cannot be considered as a polynomial because this disobeys rule number 1, right? Because if you actually, what we say, use exponents, then it will be x to the power minus 1, which is something that violates rule number 1. So that means this doesn't come under the category of polynomials. That is why we say that all polynomials are algebraic expressions, but not all algebraic expressions are polynomials. So I hope now this is clear. Now we have different categorization of polynomials as well, that we are not going into a deep analysis of detailed polynomials, right? We'll be considering factorization as our prime objective. So let us quickly jump back to our slides now. I hope my slide is visible. So we'll be considering binomial as well as not binomial. We'll be considering quadratic polynomial as well as cubic polynomial. Now, what do we understand by quadratic and cubic? So whenever the highest power of a polynomial is 2, we classify that particular polynomial as quadratic. And when the power is 3, then we'll be classifying it as cubic. So, and the denotation will be obviously P of X or Q of X. This is something that you use in terms of representation. Whenever we want to represent any polynomial as such, the denotation that we'll be following is P of X, Q of X, R of X, S of X, whatsoever the case may be, and it depends upon the case and the author. All right. So how we actually consider this in terms of factors. So let us first revisit our definition related to factors. For this, again, I need to jump back to whiteboard. All right. So let us consider a number 6. What exactly factors are? These are normally numbers or terms, right? Which when multiplied will give you the specific product that we were taking initially for our consideration. So let us say we are considering 6, which is the number which is our prime objective. Now you need to ask it to yourself, is 6 divisible by 1? Yes. When you divide 6 by 1, you will get 6, right? So one, whatever the term by which you are dividing it, you should be writing it here. Is 6 divisible by 2? Yes, because 6 by 2 will give you 3. Is 6 divisible by 3? Yes, because 6 by 3 will give you 2. All right. Is 6 divisible by 4? Not completely. Is 6 divisible by 5? Not completely. Is 6 divisible by 6? Yes, 6 by 6 is 1. So these are the factors. That means potentially you can express 6 as 2 into 3, 3 into 2, 6 into 1, 1 into 6. So these are the factors. That means which when you actually multiply the factors, you'll be getting the number which you have initially taken for your consideration. All right. So these are nothing but the factors. So sir, what we have to do in polynomials, then how do we figure out what exactly the factors are? So there are various methods by which we can go on, but I'll be discussing two decent methods, right? That we'll be following according to our curriculum. That means splitting the middle term. That is one such case, and then we'll be going with the factor theorem as well. I hope what factor theorem is, that is something that is already stated. This is something that we'll be considering as prerequisite. Still, I'll be giving you a brief overview of what it is. Let us jump to our slides now. So this is the structure in which we express a quadratic polynomial. We'll be first saying splitting a middle term, right? How do we actually start this? So this slide looks boring in itself, but I'll give you a context and then it will look attractive to you. Now, let us go to the context as well. Ax square plus bx plus c. This is the denotation of a quadratic polynomial. You need to split the middle term. What is the middle term here? B into x. That means bx is the middle term. If you, let us say, split it in such a way, right, that p and q, when you multiply, if you can, revisit this particular part. Just a second, let me highlight the same. Yeah. If you actually retrace this, then b of x is splitted as p of x and q of x, right? So this is not obviously in addition, so that is what we have done here. When you multiply p and q, that means coefficients of x, you will be getting the product which will be equivalent to a into c. That means coefficient of x square as well as the constant term. While when you actually club them, p plus q will be giving you b only, right? So in this way, we'll be splitting it. I know it is looking abstract as of now, but we'll take an example and then it will be clear. Let us quickly jump back to our whiteboard. So let us take an example. Yeah. Okay, fine. So the example to this is, let us say x square minus 5x plus 6. This is something that we'll be considering as p of x. we need to factorize it using splitting the middle term. All right. That means this term is to be focused. Now you need to have a detailed analysis of this as well. Minus 5x is a term which is a uh, point of interest, right? We need to split it in such a way. Here, if I'll ask you what is the coefficient of x square, then it will obviously be 1, right? So you need to write what exactly A is. A is 1, B is what minus 5, and C is what plus 6. Along with the nature, you should be writing the coefficients, right? Or you should be writing the numbers if it is a constant term. We need to split it in such a way that A into C will give you what? P into Q, right? This is B of X. If you compare it with standard form, not a standard form, the denotation one, right? So B is to be splitted in P and Q, and the product of P and Q should be equal to A and C. The product comes out to be 6 plus ka 6. All right. That means this product should be 6. So we need to identify what exactly P and Q will be having. So if you take this picture into your consideration, I will be rewriting it here, x square minus 5x plus 6. We know that A into C is giving us what? 6. So we need to split the middle term in such a way that we should be getting what? Plus ka 6 as our product. So if you consider this as P and this as Q, so minus 2, when you multiply it with minus 3, you'll be getting plus ka 6. So this is a bingo situation to us. We also need to check when we add P and Q, are we getting minus ka 5, which is B of X? Yes. So if you add minus ka 2 and minus ka 3, if we have like terms, we'll be adding them, right? In this way. So this comes out to be what? Minus ka 5. That is it. So it's a bingo. That means this is the first phase which we have initiated. Next phase is what? If you actually revisit the slides, that is what we have done. See, we have splitted it in this way. Okay, just a second. Yeah. See, we have splitted it in this way, right? Now we need to take certain things which are common in order to get the exact factor. So how does that work? Let us quickly go back to our whiteboard. Let me scroll this. Okay. I hope this is clear now. So if you can actually, take x as common from first two terms. So here we have x, right? X has taken out as common. We are left with x. When you multiply this x with this x, you will get x square. Okay. And here we have 2 minus ka 2. When you multiply this x, which is outside this parenthesis with this minus 2, you will get minus 2x. Now, you need to ensure, I'll tell you this later. Here, I have taken minus ka 3 as common because if you analyze these two terms, you will be getting 3 as common, right? But I have taken minus ka 3 as common. Why is that so? Because if you multiply minus 3 with this x, you will get minus 3x. Bingo. Then, if you have minus 2 and minus 3 in multiplication, you will have plus 6. So, terms are getting adjusted. You need to ensure that these two terms are one and the same, right? Why we are ensuring that these two terms are going to be one and the same? Because if you go with left, if you go with a scan from left to right, you will be able to identify that x minus 2 is something that can be taken out as common. And here we are left with x minus 3. That means we can say that the factors of x square minus 5x plus 6 are x minus 2 and x minus 3. When you actually multiply them, you will be able to get this product. So this is what splitting the middle term is. Let us jump to our slides. I hope this particular part is clear. So they have appended one example as well. We'll be, considering this example again with the help of whiteboard. 2x square plus 5x plus 3. I'll be using a different marker. 2x square plus 5x plus 3. All right. First and the foremost thing is we need to identify what A, B, and C are, right? So if you compare it with this format, right, the standard form, my x may look like sometimes, equivalent to n. but I'll be figuring out that yes, this is something that is x, and this is whenever I used to write n, then I'll be figuring out that yes, my n is different from x, right? So we'll be try to reconfigure it once we'll actually be starting with another version of this particular shift. Fine. A is what? 2. B is what? 5. And C is 3. Right? If you compare this with this, you will be able to figure out with A, B, and C's. Fine. Okay. So this part is sorted. Now what we have to do, we need to multiply A and C. What is A and what is C? 2 and 3. It will come out to be 6. That means we need to split the middle part in such a way that the product of that split should be 6. So how that will be possible? Again, we'll be taking 3x plus 2x. Will that work good? Because when you actually add them, you will be getting 5x only, right? That will be plus ka 5. And if you multiply 3 and 2, that means this numerical coefficients will be able to get 6. Fine. So that means this split is perfect. Now what we have to do, we need to take common. So what I'll do, I'll be rearranging them. Why I have rearranged it? Because I can clearly depict that if I'll be taking first two terms, then it is very easy for me to get that common factor out. Fine, because 2 and x will come out as common. So how you are taking common? This is something that many people they keep asking. So I'll be changing the marker now, and I'll be telling you how common can be taken. If I'll be rewriting this expression 2x square, it will be 2 into x plus this will be 2 into x plus this will be 3 into x plus this will be 3. So if you take first two terms, 2 and x, right? This is something that will come out as common. So this is something that will come out as common. What is left? X. Here, what is left? 1. We have nothing left here. We need to have 1, right? When we actually multiply this with something that we have taken out as common, it should get the terms adjusted. Fine. And here, if you take 3 as common, see we have only 3, right? That can be taken out as common. So this will be x plus 1. We need to ensure that these two terms are going to be 1 in the same. Now what we have to do, we'll be taking out x plus 1 as common. When we scan it from left to right, x plus 1 can be taken out as common, and here we have 2x plus 3, right? So this is how it goes. If you can actually, go to the slides, you'll be able to find out that this is something that they have done, right? I hope this method is clear now. Although this is something that is the easier one, the difficult one will be starting right after one important node. So what important node that we have highlighted here is this method works only when the coefficient of x squared is positive. All right. Suppose if we get a situation wherein the coefficient of x squared comes out to be negative, then you should be taking -1 as common, right? Throughout the expression. So the expression will get changed. We have taken one example as well, minus 2x square plus 5x minus 3. The coefficient of x square is what? Negative. If you have taken -1 as common out of this entire expression, so it will become 2x square minus 5x plus 3. Right? Now you can apply this splitting the middle term method in 2x square minus 5x plus 3. However, that -1 is already being taken out as common. So this will be treated as one such factor. Right? So you need not worry on this part. Next is factorization using factor theorem. Now again, this is very important. Right? So let me jump to whiteboard again. If you can recall the example that we have taken, I am going to shift the marker again now. I'll be using a different color. We have taken an example which is x square minus 5x plus that is 6. Right? That is the example that we have taken. And if you can recall the factors that we got were what? X minus 2 and x minus 3. All right. So these were the factors that we got, x minus 2 and x minus 3. Now, when you actually multiply them, I told you that you will be getting the original product back. Right? That is what factors are. We'll be, considering this in a different way. I'll give you a context of what remainder theorem is. Right? You take one factor, x minus 2, put it equals 0. You'll get the value of x as 2. Whatever the value that you have got, right? Try to substitute this value. Let us consider this as p of x. Try to substitute this value in this p of x, right? So this will be p of 2 which will be 2 square minus 5 times 2 plus 6. What this will be? 4 minus 10 plus 6. Now what this will become? 10 minus 10, that means that is nothing but 0. So that means if we are substituting the value of factor in our expression, right, we'll get the remainder as 0. I'll give you this example with the help of numerical example, right? Let us say if we divide 16 by 2, all right. So we know that 8 times 2 into 8 will give us what? 16. 16 minus 16 is 0. So this remainder comes out to be 0. If I am saying that 2 is a factor of 16, that means the remainder will be 0. So if I say that this 2 is a factor of p of x, that means the remainder should be 0. All right. And I just wanted to give you a contextual clarity on this. Again, I am changing the marker color. Let us say we have 17. When you divide it by 2, 8 times 16, right? Remainder is 1. We can say that dividend should be equal to divisor into quotient plus remainder. Now, this is something that we have already gone through with, right? What is dividend here? 17. Divisor is what? And quotient is what? Remainder is this, right? So technically, we can express dividend in this format. I hope this is clear. All right. So people, if you can, actually reconfigure this with respect to P of X. This is something that we have taken in numbers, right? Numerical examples are easier to take. That is why I have taken this. What about if we take, this with respect to uh, polynomials, then it will be difficult for us to analyze. So let us try to find the factor of a polynomial using factor theorem, right? Now I told you what remainder theorem is. Remainder theorem is if you are given with two different polynomials, p of x and g of x, and if you are dividing them, and if the examiner is asking you to find the remainder, then it is very easy for you to get the remainder calculated by simply checking if g of x value at a particular point in p of x. So that will give you the exact remainder. Now that is something that we'll be using in factor theorem as well. So if suppose if it is completely divisible, then this part will go, right? It will vanish. It will not be there. If suppose 16 is the case, then we'll have 2 into 8 only plus 0 as the remainder, right? So this part will completely go. So can I say that these two are the factors now? That is what factor theorem is, right? These two are the factors of 16. So likewise, suppose if the example that we were considering x square minus 5x plus 6, if I say at x equals 2, right? If you actually substitute 2 here in this p of x, you will be getting the remainder as 0. That means x minus 2, you need to bring this to this side, is considered as a factor according to factor theorem. It's a factor of given p of x. That means this p of x polynomial, right? So I'll explain you how we can calculate the other factor of quadratic polynomial. As this is going to be a quadratic polynomial, so we'll be having only two factors, right? So let us consider the same case that we are into. X square minus 5x plus 6, which is the given p of x. And we get our factor, which is x minus 2. This is one such factor. You need to analyze the maximum power. Maximum power means what? The degree, right? Degree is 2. So you should be writing x minus 2 two times with a considerable space in between. Now you check with this term. I'll be changing the marker color now. X square. You need to open a very big curly bracket because that will guide you how we can have the adjustments made. We need to have, if you look at the very first term, we need to have x square. How do we get x square? By using x minus 2. Obviously, we need to multiply this x minus 2 with x, right? If you are multiplying this x minus 2 with x, this will be getting multiplied with this. It is nothing but x square. But this will also be getting multiplied with minus 2. So it will be minus 2x. We need here what minus का 5x. If you look at the second term, right? Minus 2x is something that we already have. If we have minus 3x, then this will serve our purpose because we need to form p of x exactly using x minus 2, right? Because x minus 2 is one such factor. So if you add minus 3x, what is the term that you should be multiplying with this x minus 2? Because this particular part is now over. We need to work on this part. So if you multiply this minus 3 with x minus 2, you will have minus 3, but this minus 3 is also getting multiplied to minus 2. So this will become plus 6. Last term will get auto-adjusted. See. So that means our p of x is now ready. That means you need to focus on only this particular part. X minus 2 and minus 3, x minus 2. I told you to take x minus 2 as common. If you scan it from left to right, x minus 3 will be treated as another factor. So that is it. With the help of factor theorem, we'll be able to identify what exactly the factors are. Let us quickly jump back to our slide now. So it is simple to crack quadratic, right? But what if we, expand it? What if we go with cubic? Then that will be difficult, right? So we have taken one case, x cube minus 3x square minus 9x minus 5. We need to, factorize this using factor theorem. I told you what factor theorem is. You need to find at least one factor. How do you find at least one factor? Using hit and trial, right? So let us try to solve this because this is something that is almost, forming the end of this session. So let us solve this. I'll be changing the marker color. Let us say p of x is what? X cube minus 3x square minus 9x minus 5. All right. So if you focus on constant term, which is minus 5, what are the possible factors? Right. See, the possible factors are 1, minus 1, minus 5, and 5. Because when you actually reconfigure minus 5, then these are the possible factors that you can actually list down. Fine. So why do we need to identify possible factors of constant term? Because this is something that will be substituting in p of x or f of x, right? So that we are just checking the possibility if we get 0. If we get 0, that means factor theorem can be applied. The remainder comes out to be 0. That means that particular part can be treated as one such factor, right? According to factor theorem. Now, sir, why we are focusing on this minus 5 only? Because this will give us the numbers which are to be used for hit and trial, because ultimately the first and the foremost step is to find the numbers that you can actually substitute in f of x or p of x in order to get the zero of a polynomial. So once that zero is something that you will be able to locate, then you'll be able to possibly list down one such factor, and then everything will go in a smoother fashion. So as you can see that this particular example is having x plus 1 as one such factor. So we'll be, redefining this with the help of our own calculations. So as I told you that you should be, first checking the possible factors of minus 5, 1, minus 1, minus 5, and 5, right? Now, from this particular part, you need to select a number which when substituted in p of x shall give you what? 0. All right. So if you can, go with x equals minus 1, that means p of minus 1 is something that we'll be having. So it will be minus 1 cube, minus 3, minus 1 square, minus 9, minus 1, minus 5. So this will be minus 1, minus 3, plus 9, minus 5. So this will be giving us 0. So that means at x equals minus 1, this particular part becomes 0. The value of p of minus 1 will be 0. So this is one such 0 that we'll be considering. That means we can say from this that x plus 1 is one such factor of this. Now I told you that I'll be rewriting p of x here with a different marker. X cube minus 3x square minus 9x minus 5. Yes. So x plus 1 is one such factor, right? That is what we have calculated. Check with the highest power, which is 3. Write x plus 1 3 times with equal spaces. Now we need to form this p of x using this x plus 1. I told you to have long curly brackets. Focus on the first term, which is x cubed. Right? How do you get x cubed using x plus 1? When you multiply it with x square. So this will be what? X cubed. And this will also be getting multiplied to plus ka 1, right? Plus 1. So it will be x plus ka x square. We need to have, in the second term, we need to have minus 3x square. That means this particular plus 4x square should be, having a coordination with minus 4x square. Plus ka x square and minus ka 4x square will give you what? Minus 3x square. How do you get minus ka 4x square here? Using this term, because this term is exhausted now. So obviously, when you multiply it with minus ka 4x, you'll be having minus ka 4x square here. This minus ka 4x will also be getting multiplied to plus ka 1. So that is nothing but minus 4x. We need to have minus ka 9x here according to the next term. Right? This term is exhausted now. So only this is left. We need to adjust the terms accordingly. That means we at least need to have minus ka 5x here in order to have minus ka 9x according to p of x. How do we have minus 5x when you actually multiply this with minus 5? Minus 5 into x will be minus 5. And last term I told you will go in auto adjustment. When you multiply minus 5 with plus 1, you'll be having minus 5. So that's it. This is our p of x, right? So our point of interest will be this area, right? So I'll be rewriting our point of interest, which is x square, x plus 1 minus 4x, x plus 1 minus 5, x plus 1. If you scan it from left to right, x plus 1 can be taken out as common. So we have x square minus 4x minus 5. Again, this is a quadratic function. We need to further split it, right? We'll be having two factors. We won't be having more than two. We'll be having two factors. Both of them can be identical, right? So I told you, you can use splitting the middle term as well. Otherwise, you can again go with hit and trial, and then you can, reconfigure what exactly the factor of this will be. Although if you are approaching it using factor theorem, then it is recommended to go with factor theorem only. All right. So I'll be considering factor theorem only, but you can use splitting the middle term. So what I'll do, I'll be first mixing it with splitting the middle term, and then we'll be slowly moving with what we call uh, factor theorem, right? So first we'll be doing it with splitting the middle term. So I have split the middle term in this way, right? Minus 5x plus x which will give you minus 4x, and when you multiply minus 5 and plus 1, you will have minus 5, right? A into c. So here a will be what? 1, b is what? Minus 4, and c is minus 5. Right? A into C will be what? Minus 5 only. Fine, people. So if you can, take common, then this will be okay. I'll be rearranging this. Now, sir, how do you determine that? Yes, you need to have a rearrangement, because I can see that maximum things that I can take out as common, or that can be taken out as common, will actually do my job, right? So that is how I restructure. X can be taken out as common, so it will be x plus 1. Minus 5 can be taken out as common, so it will be x plus 1. Right? X plus 1. This will be again x plus 1 and x minus 5. That is it. So these are the two factors that we get. You can club x plus 1 as x plus 1 whole square, but no need to club it, as we are already doing, a factorization. So we just need to specify that these are the factors. Otherwise, this will work good. All right. So if we can actually have a look here, x plus 1, and x minus 5 will come out to be this. They have taken this using method number 1. Method number 1 is long division method, and method number 2 is exactly what we have done. So here they have used splitting the middle term, although you can, go with the factorization as well, right? The point is, you just need to identify what exactly, the zero of a polynomial is, and accordingly you will be checking with other factors. Fine. What is method 1 here? Method 1 is division, right? How do you get method 1, sir? x plus 1 is something that we got, right? Method 2, I have explained you. This is exactly using factor theorem. But how do you get method number 1? So let us have a look here. X plus 1 is something that we have got. And I told you this is nothing but division. How do we get factors? When we divide them, I'll be changing the marker. X cube, I'm rewriting the polynomial. X cube plus, x cube minus 3x square minus 9x minus 5, right? And x plus 1 is one such factor. So this is our p of x. And let us say our g of x will be x plus 1. When you divide this p of x with g of x, right? Let us divide them and let us see how things will go. Focus on the first term. First term is x cube. How do you get x cube? When you multiply this x plus 1 with x square. So let us say if you multiply x square with x plus 1, what you'll get? X cube plus x square. This is something that you should be writing as it is here. X cube plus x square. Then obviously in division will be doing this change of sign. This will go away. Minus 3x minus x square will give you minus 4x square. This is something that you should be copying down. Right. Now focus on first term, which is minus 4x square. How do you get minus 4x square? Using x plus 1. Because x plus 1 is this, right? When you actually multiply this with minus ka 4x, so when you multiply this, you will get minus 4x square and minus ka 4x. Fine. So let us put minus 4x square here. Sorry, minus 4x, not 4x square. So you'll get minus 4x square and minus ka 4x. Change of sign, plus and plus. This will go. What this will be? It will give you what? Minus ka 5x, right? Which one is greater? Minus, in magnitude 9 is greater, right? What is the sign of 9, which is minus? So that sign will come. And then this minus 5 is to be copied down. Now, again, this question is going to be the same. What exactly will be, having this? We need to have minus 5, right? That is something that you need to ask it to yourself. See the first term. You need to have minus 5x. How do you get minus 5x? When you actually multiply this with minus 5. So this will become what? Minus 5x minus 5. Last term will go on auto adjustment, I told you. So that means minus 5 is something that you should be putting here. So it will be minus 5x minus 5. Change of sign, plus, plus, this and this will go away and remainder will be 0. This is something that you got. And that is the exact thing that we have considered here. See, x square minus 4x minus 5. Right? I hope the concept is now clear. So that is what method 1 was all about. And this is method 2 that we have already covered. So this method can be extended for higher degree polynomial as well. Right? So if in case you have any doubt, then doubts and queries are welcomed, and it is done from my end. Right? We'll see you in next class. Thank you. Thank you so much. Bye. Take care.